All right, we're back. We just talked about the domain restrictions that when you have a fraction, the bottom can equal 0. To finish up actually finding the inverse here, it looks very tricky, I ain't gonna lie. It's like, well, there's two y's now. Oh my gosh, how am I supposed to get y by itself if there's two of them? And honestly, it's definitely not immediately obvious. It turns out, and we'll get practice with this later in a completely different unit, but whenever you're trying to simplify a fraction, you always want to factor it. The top you can't factor, but the bottom you can actually pull out a GCF of a 2, like that. And you know here you can't pull out anything. But what does happen is that you have a 2 minus y on top and a 2 minus y on bottom. I mean, you could cancel them. In which case there's just a 1 left up top and a 2 left on bottom, meaning it says x equals 1/2. And bada bing, bada boom. That's actually all that's left. It's impossible to solve for y because there's no y left. So that would be the inverse. And once again, this would not actually be a function. Just that. Over here is the other example. I like to say it's harder because it's easier. As you can see, it does not have all the bells and whistles of this one. But a lot of times when things are easier in math, people get confused because they think there's supposed to be 7 steps, just like the previous problem, even if it's just 1. So the first thing you do is set the bottom equal to 0, or not equal to 0, I should say. So the bottom is x, and if you set it not equal to 0, congratulations, you are done. There is no more solving for x. You're just done. The domain restriction is that x is not 0. The next thing is that you were supposed to change this to be x equals 1 over y. And you have to get y by itself. And the way you would do that is you would multiply both sides by y. That way this goes away, and you get yx equals 1, and then you would divide by x to get y equals 1 over x. Like so. That's the very kind of formal way to do it. Yeah, okay. So on the next page is something different. It's reviewing composition of functions. It's going to be, this technically has nothing to do with inverses, but we will be using composition of functions on the next part. So I do want to talk about it. It says given a function f, x going to f of x, and g is x going to g of x, the composition of function of f and g will convert x to f of g of x. That is a lot of math speech. It just says, hey, we're going to do a composition of function, f of g of x. This is another notation for the exact same thing. This is f of g of x. This is f of g. They just don't put the x, but sometimes they will. It's used to represent the composite function. So here we go. F of g of x equals this, or f of g is the function that takes x and puts it into the composition. Anyway, here's how it goes. If f is 2x plus 1 and g is 3 minus 4x, and it wants to do a composition of function, basically what's happening is it's saying to take g and plug it in to f. So f used to be like 2x plus 1, 2x plus 1, but it's saying don't use x, don't use the variable x, use the variable g, right? Instead of 2x plus 1, it's 2g plus 1, because g is being plugged into f. But then you can go over here and say, well, what was g? Well, g is 3 minus 4x. So you put g in for x, and then whatever g is, you write it down, and then you simplify. In this case, it's going to be distributing and then combining like terms. Like that. So that is the answer. It's the simplified version of it. It's the second letter going into the first. Just remember that. No matter the notation, like whether it's this notation or that notation right there, it's always the second letter going into the first. So in this one, it says f of g. That means you're going to write g down, which is 3 minus 4x, but instead of x, it's an f. 3 minus 4 f, right? Because f is going into g, so f is going into g. You would make this an f, 3 minus 4 f. But then f is 2x plus 1. And you would once again have to distribute. Make sure you're distributing a negative 4. So that would be a minus 8x minus 4. And if you combine like terms, the 3 and the minus 4, that's a minus 1. So do note that they are different. They will be different most of the time. Okay, and the next one, now we have some numbers for these ones. There's a couple of ways to do this. You could do the composition function first and then plug in 2, but that's not what I actually do. I tend to take 2 and plug it into g, and whatever number I get, I then plug that into f. So 2 going into g, just do g2. If you plug 2 into g, plugging 2 into g, that would be 4 plus 3 is 7, right? So 4 plus 3 is 7. And 7 is what you then go to plug in to f, the next letter. So you plug 2 into g, you got 7, you take 7, and you plug it in to f, which is x squared minus x. So you take the 7, you plug it in, and you get 7 squared minus 7, which is 49 minus 7, which is the answer to everything, 42. Same thing over here. Take the 1 and plug it into f. So if you plug in 1 for f, it would be 1 squared minus 1, which is 1 minus 1, which is 0. So then you take 0 and you plug it in to g. So 2 times 0 plus 3. Like that. Okay. Once again, if you ever feel I'm going too fast, you can pause it, you can rewind it, whatever. But that's what's going on. You plug in 1 to f, you got 0. Plug in 0 to g, you get that. Okay, next up, going back to the actual functions, there's no x anymore. You're still taking g and putting it in where f is. So g is going inside of f. So g is going inside of f. So it's going to be g squared minus g. Right? F, and instead of g, x, you put g. For this one, it would be the opposite. If you have g, you would start with g, and then you'd put f where it is. So it would be 2f plus 3 is how you would write that out. And then you look and say, well, g was 2x plus 3. So it would be 2x plus 3 squared minus 2x plus 3. And this is a pain to simplify. This one, not as much. F is just x squared minus x plus 3. So this one involves distributing and combining like terms, which there actually won't be any like terms, so never mind. We'll do that first because it's less annoying than the other one. Ta-da! But this one, why is it pain in the butt? It's because you have something squared. 2x plus 3 squared is not an easy thing to do. If in your mind right now you're going, oh, well, don't you just do that? You're wrong. You don't just do that. If you think it's easy, you're probably doing it wrong. If you have a binomial, meaning there's two terms, and it's being squared, you have to write it twice and FOIL. There is no trick besides that. I mean, there is, but I ain't going to talk about that. Here, I'm just going to distribute the negative sign. And you would need to FOIL it. So 2x times 2x. 2x times 3. 3 times 2x. 3 times 3. Pause that if you need to until it makes sense to you what I did. These are like terms. So 6 plus 6 is 12. 12 minus 2 is 10. And then you have this 9, and this minus 3 makes a plus 6. That's it. Okay. So that is composition of functions. And we're going to get on to a whole bunch of stuff afterwards, but okay, that's it for this video. See you in a bit.